Alright, today's topic is 5-7, which is exponential equations and changing of bases. Today's date is today. And our objective today, we are going to solve exponential equations and to change logarithms from one base to another. I thought it would be fun if we could start off with a word problem. I went ahead and also wrote down what formula we would be using on this. A of t equals a naught times quantity 1 plus r to the t. Well, our initial amount is 5.4 billion, and they're asking us how long it's going to take before there will be 8 billion, so that's my ending amount. My rate of growth is 1.95%, which is 0.0195, and t is what's unknown. So let's go ahead and plug in what we know. 8 equals 5.4, 1 plus 0.019, to the t. I'm going to go ahead and I'm going to start by dividing both sides by 5.4, and I would suggest you have a calculator. I'm going to write down the approximate value, but I'm going to keep it in my calculator, 1.48, and it actually keeps on repeating, 1.48, 148, 148 equals 1.019 to the t. Well, there's really no good way at this point that we have known to solve it, but we've been doing a lot with logarithms in this chapter. So what if we took the log of both sides? And I'm taking the common log. And one thing I know about the previous section is if I've got an exponent, I can move it out in front. So I'm going to have log of 1.48 equals t times the log of 1.019. I'm going to go ahead and divide both sides by the log of 1.019. When you are doing this in your calculator, you're going to type in the log and then the 1.48148. Make sure you close your parentheses. If you do not close your parentheses, you will get the incorrect answer. Divided by log of 1.019. And I forgot a 5. And when I do that, I get 20.35. So we started at the year 1990. We're going to add 20 years to that. That would be 2010. One of the things that's going to help us be able to solve equations a lot easier is what we call the change of base formula. The change of base is really useful because our calculators, there's a couple calculators out there that can do this, but for the most part, our calculators can only do natural log and base 10. This is a way to kind of get around it. What you do is I'm going to take the log of 32, and I'm going to use the natural log. It's a base 10, I don't write that down. And then you divide it by the log of whatever base it had. In this case, it was 4. Every once in a while, there's a temptation to go, well, that would be the log of 8. Don't do that. You actually have to physically type in the log of 32, close your parenthesis, divided by the log of 4. And when you do that, we're going to get, let's see, log of 32 divided by the log of 8. I get 1.67. And instead of an equal sign, I probably should use approximate because I rounded it. It's actually 1.6 for heating. Let's do another one. That would be the log of 1 divided by the log of 8. And when you do that, it's 0. Make a mental note of this. Whenever you take the log of 1, no matter what the base, it's always going to be 0. Log 11 divided by the log of 9. And that one, I get that it's going to be 1.0913. Okay, so let's take a look at now some equations, and we're probably going to be using that change of base to help us out. On this one, I have an exponential. I have 5x equals 15. Early on in the chapter, I said an exponential and a log can cancel each other out. So what I'm going to do is I'm going to take a log of both sides. But I notice my base, 5 to the x, the base is 5. I'm going to make my log a base 5. And the way you can think about it is these two cancel each other out, and you're left with x. And we've got log base 5 of 15. Well, that would just be the log of 15 divided by the log of 5. And don't say that it's going to be 3. It's going to be 1.6826. So on our next example, I have 8 to the x. What I'm going to do is I'm going to take the log base 8 of 8 to the x and do that on the other side as well. The cube root of 3. That would also be the same as 3 to the 1/3. What happens? And think of those as canceling themselves out, and you're left with an x. And that'll be log of the cube root of 3 over the log of 8. And when I do that, I get 0.1761. On our last example there, I have 9 to the x plus 7 equals 15. Before I take the log of both sides, I want to kind of isolate that 9 to the x. So I need to subtract 7. And I get 9 to the x equals 8. Then I'm going to take both sides of log base 9. That's going to be log 8 divided by log 9. I'm going to get 0.9464. All right, on this one, it's really the same thing, but we've got an e. As soon as I see e, I should think natural log. So I'm going to take the natural log of both sides. The natural log and the e cancel each other out. I'm left with x. Then on this one, you just have to type in what the natural log of 12 is. Get 2, approximately 2.4849. On this example, I want to isolate that e to the x, so I first need to subtract 3. 7 e to the x equals 9. Divide by 7. Then I'm going to take the natural log of both sides. X is going to equal the natural log of 9/7. And I get that it'll be approximately 0.2513. All right, that's solving exponentials. I hope you enjoyed yourself.